Welcome. This is Convergence. My name's Michael Doran. I'm a California attorney. Today's episode is going to be about the drought in specifically the low water levels in the western United States. I'm going to repeat it. It's the theme. Albert Einstein said among the most difficult problems in all of physics is Earth's magnetic field. I believe it's the most difficult problem in all of biology. I may run out of time here. I'm going to do the best I can to put it all together, but I'm going to start out with the life part, and then we'll get into the electric part, or to the Earth magnetic field part. The life part, I want to talk about methanogens. When you talk about early life, and I made this joke earlier that if an amoeba is a simple life form, try to make one. And so I realized that life is very complex. But among the early forms of life, they're called extremophiles because they lived in such extreme conditions. Today we're going to talk about methanogens. Those are the microbes that make methane, or CH4. And specifically I want to talk about a chemical called a methane hydrate. Methane hydrate is a CH4 methane molecule that, because methane is very stable, but under tremendous pressures, and we're talking 1,500 meters of ocean, under those kind of pressures and really cold temperatures, there's a thermohaline, there's a layer of warmer ocean, and then as you get down below, the ocean gets much colder at depths. It's stratified. You get very cold ocean and high pressures, and under those conditions, a methane molecule can be surrounded by a water molecule and form an ice. It's called a methane hydrate. The salt gets crunched out of it, and it's a solid. But you need methane, and you need tremendous pressure and cold temperatures. Where are the methane hydrates? Well, they're in all places: the Gulf of Mexico, Gulf of California, and which is where ultimately the Colorado River flows to, and is responsible for the chemicals that make up the methane. So the methane hydrates are present in the Gulf of California. They're very unique in that if you had a block of methane hydrates in the Gulf of California, and there was nothing but methane hydrates, they would immediately come floating up and start fizzing because they're not stable under the lower pressure. In fact, these blocks of methane hydrates have been observed off the coast of Oregon, floating to the surface and fizzing, refrigerator-sized blocks of them. The reason it doesn't happen that much is because sediments will intermix with the methane hydrates, and the sediments are heavier than the methane hydrates, and it weighs the methane hydrates down. So what happens is the methane hydrates end up being very sensitive to the flow of the river and what's flowing down the river, whether it's muddy or whether it's not, and this can cause releases of methane hydrate. But you typically don't see anything even when this occurs, because the microbial biosphere will consume the methane and convert it into carbon dioxide. what ends up happening is the methane hydrates end up regulating carbonation, and, and in particular, carbonation in the Gulf of California, which is where Lake Mead comes in. So I want to go over a little bit of history, but strangely, that history goes to war-torn Ukraine and Russia. History starts with the Volga and Don rivers. The Russians wanted to, if you can take the time machine back to Mark Twain years, when so much steaming commerce went down rivers. The Volga River was no exception. It flows from Moscow to the Caspian Sea, and there was a tremendous amount of commerce with steamers going up and down. And one of the dreams of the Russians at the time was to connect the Volga River, which is landlocked, to the Don River, which goes out into the Black Sea and then out into the major oceans. And the way that they wanted to do this is to raise the level of the Don River, and then there's an area less than 50 miles, and connect those two rivers, the Don and the Volga, and that way that you could have this commerce. And the first project that they did, the Russians did, to raise the Don River high enough so they could make this canal, and I'm going to probably butcher it, it's called the Kacheskovsky Lock. And it was basically a lock and dam, and it was built on the Don River. Again, the idea to raise it up so that they could have commerce that would ultimately go through. And it wasn't until the 50s that this canal actually was completed, but the lock and dam was completed from 1914 to 1919. And that's when the first famine struck that region. It's no coincidence. It occurred from 1918 to 1920, and 9 million peasants died. There's an academic discussion of how much of these deaths were political, and how much of it was just straight starvation from poor crops. And then another 10 years go by, and there are really poor harvests from 1932 to 1935. Well, what happened at that time? There was a massive dam built on the Dnieper River, which is it was built on the I'm going to butcher this, Zaporizhzhia, and this has been in the news, by the way. So there's a huge nuclear plant on the other side of another reservoir that the Russians have, and then Zaporizhzhia is now where the Ukraine is still holding that. But that dam and the power station are different. The power station, nuclear power station, is actually not in Zaporizhzhia. It's south of there, across a reservoir that's a second reservoir. But I'm talking about a dam that was above the second reservoir. And I know, and this really gets to the issue here, because even though there was a massive dam, and we're talking about the stability of methane hydrate fields, and therefore carbonation in the near shore sea in this case, and then whether there's rain feedbacks to the region and all the lightning and so forth that goes with it. There's a difference between then and now, and I'll shortly explain. Same time, this is occurring in the early 30s. The United States built Hoover Dam, and this is where Lake Mead is, and this is where the very low Lake Mead is that's in the news now. The Lake Mead is the largest reservoir by volume when full in the United States. It's on the Colorado that eventually flows to the Gulf of California. It was completed. I'm sorry. The diversion of the river occurred on November 13, 1932, and they did it in the fall when the Colorado was normally low, and then the tunneling began in 1931, and they made a temporary coffer dam. The Dust Bowl, the dry years basically went for during the construction. The worst year was 1933, 38 dust storms. One was particularly horrific in South Dakota in November of 1933. In 1933 also, and this is where there's two common things between what in Ukraine they call the Holodomor, which means murder by hunger. And again, Stalin was guilty of some horrific policies, there's no question, but there was famine too, and it was so the intermixing of politics and how people were managed and the famine have to be seen kind of intertwined. But there were poor harvests from 1932 to 1935 in the region of Ukraine. So, and the river there again is the Dnieper River, and we're talking about the Zaporizhia Dam that was completed in 1932. It was blown up by by Stalin in 8/18 of 41 to make it more difficult for the Germans and Hitler who was invading Ukraine at that time. But I'm more talking about it in terms of the Dust Bowl years that we had here and they had there. So in 1933, in September of 1933, there was only 3.5 sunspots. It was the low sunspot level in cycle 17. The same time of the solar minimum in the early 30s, there was also the previous sunspot cycle had a low during the very dry and famine conditions in Russia when they had poor harvests from 1920 to 1921. This is related to the fact that when the sun is quiet, then cosmic rays come in high, and it's another way of saying that you have a lot of protons coming into, it is an input into the Earth's system. And we've had just that the last several years, I would say from 2017 to now, we've had, and now we're directly measuring the cosmic rays, but as the solar activity has been slow, the sun basically is allowing a higher flow of cosmic rays to come in, and that's basically protons. That goes right to your Pacific high, it goes right to high pressure systems and enhances them and blocks rain events from coming in. But it's more than that, it's also about a lack of carbonation in these basins because they were interrupted by the changes to the river from the dams. A really good question, I believe, is, well, why don't we see the same kind of dust bowls today? Well, since 19 I would say 40, just right after the war, we've had, and this is, by the way, I have a commemorative stamp of the dam that was built on the Dnieper River, kind of like the stamps we're seeing now. That people were very proud of this stamp, even though they didn't realize it was behind the death of so many people from starvation. 12 million people died in the Holodomor. And I know some of it was politically driven, but you think something is good for your country, and it turns out to be to kill people from famine. So what I want to show you is global fertilizer consumption. This is just off Wiki. And again, you probably can't see it, but I'll tell you what it says. It says from around 1910 to 1940, it grew from 0 to less than 25 million tons of nutrients. And today, we're over 275 million tons of nutrients. So what we're doing is we're taking fossil fertilizers from outside of the active biosphere, and we're using them on our soils. And then that results in higher carbonation levels in our downflow in the nearshore oceans where the rivers exit. And the best example of this you can see satellite images of it quite clearly is the phytoplankton blooms in the Gulf of Mexico this year. The entire northern half of the Gulf of Mexico, all the way from the delta of the Rio Grande to the Florida coast, this massive area of phytoplankton bloom. And that's going to affect your carbonation levels. It's a different input to the carbonation levels than what you would see from methane hydrates being released and how they're released seasonally from river flows. But in the 30s, the Dust Bowl and here in the Holodomor and Ukraine were related to these two massive dams, and the impact that they had on hydrates, the delay of flow, and this is already in the context of high cosmic rays from the solar minimum. So now we have high cosmic rays, in the context of the solar minimum, and the West is in a horrific drought. But and though the rivers are falling, but not the rivers are falling, the reservoirs are falling. But this is being offset by fertilizers, particularly in the eastern and central United States, where the Mississippi, to some extent the Rio, are flowing high amounts of fertilizers. So the last thing I want to say about this too is, again, the idea is the Earth is alive. Again, the idea it dampens the Earth's magnetic field. Again, the idea that you have to have information and feedbacks. And one of the informations that naturally occurs with lightning is that it fixes nitrogen. This is why a thunderstorm smells the way it does. And pardon me for that. And so what we've done is we've gone out of that side of the active biosphere and what it's doing and what information it's giving to the active part of the biosphere, and we're causing defects by going outside of the active biosphere into the inactive biosphere and getting things like fertilizers and using them, using dams, changing when flows occur, and that consequently is changing the Earth's global electric circuit. And as I'm dinging here, I probably should end the show now. And I thought I was going to go a lot longer, but I kind of hit everything I wanted to hit. So good luck, have a good day, and stay safe out there.